Hello dear friends, today I'm very thrilled to have you join me for the ninth video in this total quality management series. Today we are gonna focus on understanding probability function. As I told you in the previous session that it was about the PDF and PMF, and today I'm gonna increase one more that is about the CDF. What's the PDF? PDF is probability, uh, probability discrete function, and PMF is the probability mass function. CDF is the cumulative distribution function. And today we are gonna talk about the role in quality management, and actually this concept might seem complex at first, as I told you in the previous session, but with real life examples and practical applications their significance will be clear, will become clear for you. So the probability mass function means that the PMF or probability mass function is used for discrete data. These are data points with specific and limited values, such as the number of defects in a batch of products or the number of heads in coin flips. For example, imagine that producing 100 items and wanting to know the probability of 0, 1, or 2 defects. Probability mass function helps calculate this probability. So, I'll try to bring a chart about the probability of the mass function, and I think it can be more touchable for you, and you can find something more about this. For example, as you can see in the chart, the vertical chart or the vertical axis or the x-axis is number of defects, and the horizontal is the number of defects, and the vertical is the probability, the digit of the probability. So the 0 defects shown that the 70% of the probability, as you can see, and the 1 defects in this, for example, producing show that the number of 1 defects is the probability of this is about 20%, and the number of 2 defects in our producing, the probability of this is about 10%. So this is the one tool in the statistical application software that you can use for this kind of result for your producing and for your quality of your product. So one more thing that it was about the probability density function. I mean that the PDF or probability density function is used for continuous data. I said that it is like weight or length or height or everything that is the continuous data. PDF or probability density function shows how probabilities are distributed over a range of value. For example, suppose a product's weight should be between 98 and 102 grams. The probability density function helps determine what percentage of products fall within this range. So, I try to have a chart for this part that you can see the axis X or horizontal axis show us the weight of products by grams, and the vertical axis, y axis, shows us the density, the probability of the density. This is the bell curve. This is like the bell curve that the under this bell curve is very important for us. All the data is under this curve is important for us for the probability. Okay, that for example for this session, this, all of the data that happen under this curve is important for us. These tools like the PM like the PMF, actually you can find in the some statistical software that if you give them some data about your product, about your producing, you can find some result according by the probability density function, and it is very important according by your mind, according by your report. You can use the PDF and PMF. So one more thing that I say to you, it is about the cumulative distribution function. Cumulative distribution function, this is the new for this session, because in the previous session just we talk about the PDF and PMF, but CDF is a new, and today we are gonna talk about this is more. CDF or cumulative distribution function represent the cumulative probability up to a specific value. It helps identify the percentage of data within a given range. Imagine that actually suppose you want to know what percentage of products weigh less than for example 101 grams. Cumulative distribution function provides this probability. As I said to you, you can use some statistical software. This is one tool in some statistical software like SPSS, like Python, like Excel, and something that are this kind of rules, this kind of tools you can use from them, and for your result, for your quality result, and you can use for your managing of the quality in your result, in your production. This is the chart for the cumulative distribution function, that as I told you, this is the weight of products, the x-axis, and this is the cumulative probability. So this up to a specific, this is as I told you here, this probability up to a specific value, up to a specific value. Okay, it helps identify the percentage of data within a given range. So the last one, it is about the Six Sigma. We have a conversation about the Six Sigma in the previous session. In Six Sigma, the primary goal is to reduce defects and improve quality. For this PMF, that PDF, that CDF. So PMF, as I told you, is probability mass function that analyzes discrete defects in products. And PDF, that as I told you, it was about probability density function that evaluate continuous variation like weight or length. And CDF is a cumulative distribution function, examines the percentage of products within a standard range. So imagine that in ice cream production, suppose you want to ensure 95% of the servings are between 200 and 205 milligram. Using CDF, for example, by using the CDF tools, you can calculate this percentage. So if you learn the three tools, that's PMF, PDF, and CDF, you can find some result about your quality, about your quality product. You know, this helps you. This has helped you that you remanage, restructure your processes, and actually, if you have some problem, you can solve it and then restructure. Or if not, you can solve just the point problem that happened for you. Sometimes this kind of result lead to find some bottleneck about your producing quality, about quality for your producing. You know, it is very important. I think these three tools is very important in the Six Sigma application. You know, so if you know this tool, we can find the close data to the correct data, you know. So the chart for the Six Sigma. This is the chart for the Six Sigma. This start from this. This is the mean line, so it's 0. And this is the, for example, -1 standard deviation, -2, -3, -4, -5, -6, and this is about the plus. Okay, the x-axis shows us the standard deviation, and the y-axis shows us the probability density. So this diagram represent a normal distribution showcasing the different sigma levels from actually minus and plus 1 standard deviation to minus and plus to minus and plus 1 6 and minus and plus 6 standard deviation, you know. That means that this. So showcase the different sigma levels from -1 to -6 standard deviation, and +1 to +6 standard deviation. The central peak corresponds to the mean. So this is to the mean of the processes, while the horizontal axis represents the range of possible values. Each sigma level indicates a certain percentage of data falling within the specified range. For example, +1 and -1 standard deviation covered +1 and -1 from this session until this session. For example, +1 to -1. Okay, this under the curve shown us the about 68.27% of the data, and from -2 to +2 standard deviation covers about, I mean that this part to this part, all of them this part under the curve covers about 95.45% of the data. And the last one, for example, is about the -3 to +3 standard deviation covers about 99.73% of the data. So in Six Sigma, they're focusing on achieving a quality level where 99.9996 6% percent of the products fall within the plus minus standard deviation range. This corresponds to approximately 3.4 defects per million opportunities, demonstrating as extremely high process precision and minimal variability. The further the sigma levels extend, the fewer the chance of defects, symbolizing an efficient and reliable process. This visualization is crucial for understanding how variability reduction lead to better quality and customer satisfaction. So, guys, this session is finished, and I think it's better that according by some real example you refer to the some statistical tools, statistical software, for example SPSS, and use these tools from the SPSS, for example PDF, CDF, and PMF, and find some result from your example. So I think it's better that actually rely your mind according by this kind of exercise, and you can use these tools for your own business and your job. Concepts like PMF and PDF and CDF, actually if we want to have a wrap up from the information for this session, enable us to better understanding production process and reduce defects. In quality management, these tools are fundamental for precise decision making. So please pay attention to this kind of tools that I think it can be the milestone in your life for the managing life. You can find some tools for measuring your quality about some services, about some products, about some designs, about everything in your life that you want to have some output, and you can measure with this kind of tools in the statistic. Okay guys, thank you so much for your attention, and I'm very glad for seeing you again, and I want to see again you for the next session, but for the new topic. And I think this presentation that was about the quality management had many good information about improving your quality managementing actually, and you can use this kind of tools in measuring some quality. Thank you and have a good time, and I will see you for the next session. Bye.